Let's continue with mole conversion practice. This will be the second video, problems 6, 7, 8, 9, and 10. We got 245 grams of lithium carbonate. How many moles do we have? Well, formula for lithium carbonate, Li2, and this is the polyatomic ion carbonate. So again, we really got to find out the mass of this. So lithium, we've got 2, carbon we have 1, oxygen we have 3. Lithium is 7, so that will give us 14. Carbon's 12, this is 12. Oxygen is 16, so that gives us 48. And if my math is right, it should give us 74. So we have 245 grams of Li2CO3. I just have a habit of putting my polyatomic ions in parentheses, even if there's only one unit of it. So don't be too surprised when I do that. And in 1 mole of lithium carbonate, Li2CO3, we know there's 74 grams. Li2CO3. Well, if my math again is correct on here, it's going to come out to be approximately 3.3 moles of lithium carbonate. Alright, let's go on down to problem number 7. Fold this over. Yeah, actually, I'll flip it around. Number 7. How many gold atoms do you have if you have 400 grams of gold? And again, we cannot work with grams. So we got gold. And gold has an atomic mass of, let's see if I can find gold, 197. And again, if you look at your periodic table here, and you see gold right here, I just rounded that up to 197. So we want to know how many atoms. Well, we got to start with, we got 400 grams. We got 400 grams of AU. And there are 197 grams of AU of gold in 1 mole of gold. And in 1 mole of gold, there are 6.02 times 10 to the 23rd. And again, it can be Avogadro's number, get you atoms, get you particles, get you molecules, whatever it happens to be. Atoms of AU, and it comes out to about 4.9 times 10 to the 26th atoms of gold. So there's problem number 7. Alright, let's look at problem number 8. 68.5 grams of a certain compound contains 5.25 times 10 to the 23rd molecules. What is the molar mass of this particular compound? Alright, this is a little bit different take. So we need to find the molar mass of the compound, and we've got that many molecules. So we know there's 6.02 times 10 to the 23rd molecules in 1 mole of the compound. So let's get to moles first, because as we mentioned, that's always kind of the great equalizer. And I'm 5.25 times 10 to the 23rd molecules, and I'm just for grins, let's just call it X. Probably call it anything you want. And we know 1 mole X contains 6.02 times 10 to the 23rd molecules of X. So let's see how many moles of X I have. I have, if I do my math out here, I have 0.87 moles of X. So 0.87 moles is 68.5 grams. So what is 1 mole? Well, from here we can set up a pretty simple ratio. So we can say 68.5 grams, and I'm going to leave the X out of this, is to 0.87 moles. Well, we don't know the mass, so this is the unknown, and we really want 1 mole. So we can cross multiply this times this times that, and then we, well, I guess I might as well just do it out. 0.87 and times my unknown equals 68.5, and the moles are going to cancel out. So how do I get this by itself? Divide each side. So my unknown ends up being approximately 78.7 grams. Kind of an interesting problem. Alright, let's look at problem number 9. How many grams are there in a container of 2.26 times 10 to 25th molecules of dinitrogen trisulfide? And again, how many grams? We're going to need mass. So dinitrogen trisulfide. Whoops. So that'd be S3. So for this particular problem, we need, let's go ahead and do it. So for nitrogen, I have 2. Sulfur, I have 3. Nitrogen, I know is 14. So that's 28. Sulfur, let's look that one up. Sulfur's 32. And 32 times 3 equals 96. And if I add that together, 86 is 14. Should be 124. Alright, so we can start the problem. We got that many molecules. So we have 2.26 times 10 to the 25th molecules of dinitrogen. Yeah, I'm just going to write it up here. N2S3 all over 1. And we know there are 6.02 times 10 to the 23rd, again, molecules of N2S3 in 1 mole of N2S3. And we still want grams, so we got one more step. In 1 mole of N2S3, there's 124 grams. N2S3. And again, canceling out is our savior here. And if this comes out right, it's going to end up being, this seems like a really big number. Yeah, let's do this one. See if I can plug this one in, see what we get. Again, multiply the numerators, divide by the denominators. So I have 2.26 EE to the 25th times 124. So I get that value divided by the denominators, 6.02 EE to the 23rd. equals, that's a pretty big number, 4,655 grams. So if my math is correct here, because that's a whole lot of particles when we go to the 25th on there. Alright, let's look at the very last one, number 10. How many molecules? Yeah, let's see if I get this folded here. How many molecules are there in N2O5? Alright, we got 325 grams. So N2O5. Nitrogen is 2, and I know that's 14. So that's going to equal 28. Oxygen, I have 5. I know that's 16. So that's going to equal, on this part here, that's going to equal 80. So it comes out to be 108. How many molecules? Got to change grams to moles and moles to molecules. So I have 325 grams of N2O5. And I know there are 108 grams of N2O5 in 1 mole. N2O5. And I know in 1 mole of N2O5 there are 6.02 times 10 to the 23rd molecules, and I'm going to write up N2O5 up there. So that is going to equal 1.8 times 10 to the 24th molecules of N2O5. Alright, this takes care of the front page, and again, don't be afraid to check my math.